Hello students, I welcome you all on my YouTube channel. In this video we are going to start another section, section B of differential equation. This section we will be trying to solve linear equations with constant coefficient. Linear equation with constant coefficient. So as we did earlier, what are linear equations? Okay, linear equations are those equations in which degree of derivative coefficient differential is 1 only, and degree of dependent variable is 1 only. Or alternatively we can say, if derivative is not getting multiplied with derivative, and derivative is not getting multiplied with independent variable, and independent variable is not getting multiplied with itself, if all these three things are not happening, the equation, then we call this equation linear equation, right? See here, I'm going to give you example here. Here we are having p naught, which is function of x. So not writing it, tell that p naught is function of n by dx, differentiation of y, nth differentiation of y with respect to, plus p1 p n minus 1 minus 1th differentiation of y with respect to, plus so on to p n minus 1 dy plus y. Okay, since as I told you earlier, here pi's, all p's are function of x on, right? So you see, there is no derivative being multiplied with each other, derivative is not getting multiplied with derivative, and independent variable is not getting with, this is the independent variable here, so it is not getting multiplied itself. So this equation is linear. Okay, also you see, pi's are function of x on. If pi's would have been the function of x and y, then it wouldn't have been linear equation, because y would have been then multiplied with derivative, right? And now if we take all these pi's, right now they are function of x. If these are constants, then we call this equation linear equation with coefficient. Moreover, a linear equation is further divided into two types. One is homogeneous, second is, this is q, right? This is q, function of x and, see, if it is non-zero, then equation is called non-homogeneous linear equation with constant coefficient. And if it is equal to 0, then this equation is non-homogeneous linear equation with constant. Okay, I hope you get it. Firstly, you see, what are linear equations? Linear equations are those equations which derivative is not getting multiplied, and derivative is not getting multiplied with independent variable. Independent variable is not getting multiplied with, and if all the coefficients are constant, then this equation is naturally obviously known as linear equation with constant coefficient, right? Now you see, if right inside q is 0, then this equation will be called homogeneous, otherwise it would be non-homogeneous. Pretty clear. Now symbolic form of an symbolic, this equation can be also written as, okay, 1 d, and here what is d is, okay, this is your dn plus so on n minus 1 d plus d, bracket y outside equal to, this is known as symbolic, this form is known as symbolic form given differential. This whole thing is function of d, so we write it f d y, okay, where f d is equal to p naught dn plus p1 dn minus n minus plus. Now if we compare this f d 0, that is p naught dn 1 dn minus 1 so on n is equal to 0, then this is known as auxiliary of given differential, auxiliary or auxiliary auxiliary differential. Actually, we will try to see how to solve this. As I told you earlier, this in this video we are going to how to solve linear homogeneous differential equation, linear homogeneous differential equation with constant. Let me write it here. How to solve differential equation with constant. This video we will be discussing this only, how to solve linear equation with different with, so let me write it, how linear homogeneous differential equation with constant coefficient like looks like p naught, where p are constant would be 2 5 7 minus differentiation of and differentiation of y with respect to plus 1 1 dy of x plus n is equal to 0, because we are we are going to solve linear homogeneous differential, 0 here. So we know symbolic form is written as, if we want to write this equation, what p plus p, forgot to write y here. Y is equal to, and auxiliary equation is p 1 p n minus 1 plus so on p plus n is equal to, this is your auxiliary. Now since we know this is here, p naught, p1, p, all these terms are sense, therefore this is an equation, this is an algebraic equation. So we know if we are having an algebraic equation, we can solve it out, right? So we would be having at least most n root. Okay, this equation will certainly will be having some roots. Okay, and how many roots will be there? Like at most ज़्यादा से ज़्यादा n root will be. We are going to, these roots may be real, these may be repeated real, these may be complex. So first case 1, if that roots are m1, let me write it. If auxiliary equation, firstly auxiliary equation having real and distinct root, different, all roots are, okay, assume that let m1 and be an distinct of auxiliary, then solution then solution of given differential equation will be given by exponential given time, t is constant here, t1 e raised to power 1x plus t2 m2x plus 3 plus so on n minus 1 e raised to power x plus n e raised to power, so this will be solution. This, for example, I'm gonna take an example for you. For example, e square double derivative of y with respect to x minus 7 dy over dx plus 12 equal to, this is linear equation, linear homogeneous equation with, and here 7 is constant. Symbolic form is symbolic form D2 7D y. Auxiliary equation is d square minus 7d plus 12 0. This is quadratic equation. We know how to solve the quadratic. Can be factorized into d minus 4 into 3. So d is equal to 4 comma. These are two real as well as. Therefore, solution in this case would be for solution is क्या हो जाएगा y is equal to c1 e raised to power 4 plus c2 e raised to power. This is the okay. You can check it out. You can verify this solution. Is it solution of given not? Now, nextly, if case 2 auxiliary equation having real and repeated auxiliary equation having real and repeated is all roots will be not distinct, right? Like there would be some root which would be repeating. For example, there are some roots are distinct, but there is one root m which is repeating itself. R will I'll later tell this thing with the help of it. In this case, solution would be y is equal to c1 e raised to power m1 x plus 2 e raised to power mx plus so on, all those roots which are distinct and of this root, repeated root. Write the repeated root. Firstly, I'm going to write this repeated root. For this, you write c1 e raised to power plus it is repeating itself r time. So therefore, it would be e2 x e raised to power. We are going to multiply this by x. Okay, e raised to power plus 2 x square e raised to power so on, where c r x raised to power r minus 1 e raised to power, because it is repeating itself up to it is repeating itself r time. There we are going to get r terms, then rest of the okay. So let us try to look at case with the help of, for example, the cube or 3 time differentiation of y with respect to x minus 3 y plus 4y symbolic form is d cube minus y is equal to, right, and auxiliary equation is d cube minus 3d square plus 4 is equal to. Now we will be trying, we will be finding out its solution. Okay, so what could be its solution? Obviously, as you can see, you try, this is your x, right, x cube minus here plus 4 is equal to 0. This is your equation. If x is equal to minus 1, minus 1, 3 plus 4, which is equal to 0. So x minus 1 of equation. It means x plus 1 would be the factor of, so one root is t is equal to is 1 root auxiliary, right, t is equal to minus 1 is t, right. So how to find out the rest of the root? uh, there are two methods. One is you just one method is you just apply long division. Apply is divide d cube minus 3d square plus 4 by d plus, and another method is, which I'm not suggesting this because it is, so I'll be applying synthetic division. It is also called Homogenous. In this we are going to write all the coefficients of equations, like coefficient of d cube is 1, coefficients of coefficient of d square is minus 3, coefficient of d is 0, and last is, now we know one of the root is minus 1. Okay, minus 1. Now write this thing as it is here. Now multiply this one to, we get, now add these, we get, now multiply this minus 4 to this number again, we get, so 4, add these two number, add these two number, we get 4 again. Now multiply this 4 with minus 1 again, so we get minus we are having this 0 implies that -1 is the one of the root of equation. Okay, if we are not getting 0 here, it means this -1 of 1, right? So now we have found out the so now we have found out the we have done this synthetic division. One root is 3 is equal to, now another 2 root over here, another other, because this equation is having degree 3, so it must be having at most 3 roots, right? Other one we have found out, other 2 roots are given by these 3 numbers. First is you write d square minus 4d plus 4 is equal to 0. Other 2 roots will be given by this equation. Or same is the process of division. Long division is also will be again giving the, you have done this earlier classes, so you have already done how to find out the roots of cubic equation, long division. That's why I'm not just want to get more clarity of concept. You just look into your elementary book. You know this can be written as d minus 2 whole square equal to 2. Therefore d equal to comma 2 r other 2. So it is having 3 roots, which are, these are the roots of given differential. You see this 2 has been repeated 2 times, right? Okay, so the case 2 comes into the picture. Now the solution will be given by, in this case, so the solution y is equal to c1 e raised to power plus, again we are going to write e raised to power 2x, c2 again we are going to write, but we are going to multiply this by, otherwise this and this would be quite. Lastly e raised to c3 e raised to power, so this is the, when root is getting root is repeating itself, you just write that root one more time and multiply it by, if it would have been repeated 3 times, we could have added another term x square c3 e raised to power. This is the solution for the repeated roots of auxiliary, right? Now case 3, auxiliary equation having complex roots. We know if alpha plus iota beta is one of the root of given differential equation, then other root would be, certainly would be alpha minus iota beta, because complex root always occurs in pairs, right? So therefore solution, if we are having these two roots, solution in this case would be y is equal to c1 exponential of alpha plus iota beta x plus c2 e raised to power alpha minus iota beta, right? Now it can be written as c1 e raised to power alpha x into c raised to power root, right, iota beta x plus c2 e raised to power alpha x c into e raised to power minus iota beta x, right? We know Euler theorem on complex numbers. E iota x is equal to cos x plus iota sin x, right? So therefore we can replace iota x, the exponential of iota beta x, by cos beta x plus iota sin beta x, okay, beta or beta x plus c2 e raised to power alpha x, okay, cos of beta x minus iota sin beta x. Again taking e raised to power alpha x common, we will be having inside c1 cos beta x plus iota c1 sin beta x plus c2 cos beta x minus c2 iota sin beta x, okay, sin beta. Now e raised to power alpha x cos beta common, inside you will be having c1, see here is cos beta, here is cos beta, right? So you can club these terms and you will be getting c1 plus c2 cos beta plus, again you see this and this term, this term and this term, clubbing these two terms we get iota c1 minus iota c2 sin beta, okay, and name this c1 plus c2 capital C1 and this capital C, okay. So thus you are having solution of this alpha x c1 capital C1 cos beta x plus c2 sin beta. This is the solution when auxiliary equation is having complex, okay. Let us take one example in order to get clear idea of this thing. Okay, see example 3. Double derivative of y plus 4 times single derivative of y plus 13 equal to 0. Symbolic form is d square plus 4d plus 13 y outside equal to 0 Therefore auxiliary equation is d square plus 4d plus 13 is equal to. Now roots can be found out by using b square minus 4ac divided by 2a, right? So d is equal to minus b minus, that is 4, plus minus 16 minus 4 times 13, that is 52 divided by 2a, 2 into 1, which is equal to, solving this you just see it is minus 4 plus minus 36 root, and it can be written as minus 36 minus 36, which can be written 6 iota, okay, 6 iota divided by, which is equal to minus 2 plus minus 3 iota, okay, cancelling this. So we have two roots here. One is minus 2 plus 3 iota and minus 2. Okay. So as I told you earlier, a complex root always comes in, sign is only changing. So now solution would be given by, what would be solution in this case? Y is equal to e raised to power alpha. What is alpha here? Minus 2 is alpha. So exponential of minus 2x into c1 cos of beta x. Beta is 3 here. Okay. 3x plus c2 sin gain of differential. Okay. So this is it for today. Rest of the things will be done